Okay, so this is chapter 7. We're starting from the beginning on page 197 and we're reviewing. So the first part of the chapter we learn about stoichiometry, which is just analyzing something, a balanced chemical equation. It's like a recipe. It tells us how much of everything that we need to make the amount that we want, and we can analyze it and move between different measurable quantities, and we call that stoichiometry. It's just analyzing and doing some ratios and some um, proportions. So the first thing that we learn is about counting atoms. So we can say, if we look at the periodic table, we can say what the average mass is. So on our periodic table, each of the things looks like this. And underneath we have a number, and on top we have a number. And when we look at these numbers, it tells us different things. So it tells us that if we have, on average, a nitrogen atom, it's going to have a mass of 14.01 AMU. That would be if we had one nitrogen atom. We probably wouldn't have just one because nitrogen is diatomic, and we were going to find it in nature as N2. So if we had one of those, though, that's how much we would expect it to be about. That's an average. The AMU is made by adding the all the pretending we can add all the things in the universe, all the nitrogen atoms, and divide by how many we added. We could add up all their different masses, divide by how many we counted, and then we would get this number. So this is just an average. An individual would have like probably about 14, which means it'd have 7 protons and 7 neutrons. This number is also important, though, and the book goes through a lot of different explanations about it. But the important thing that you need to know if you take this number is that this number also means something else. This number also means that if we have 1 mole of nitrogen atoms, I'm not going to write the whole word, then that 1 mole would weigh, or not weigh, would have a mass of 14.01 grams. And we learn as we go through the math of this first section, and this first section is called Counting Atoms. If we go through the math of it and go through the book, we learn that there's a special number called Avogadro's number. Gotta look at it so I don't spell it wrong. And Avogadro's number it's a constant. We have like a rounded version. A lot of math books will have, science books will have another digit. They'll have another digit there. We're not worrying about that. We're going to stop at just 3 digits. Avogadro's number is a special number that tells us how many. Like 1 dozen is 12. 1 mole is this number. And we could write that out with, if we move the decimal 23 places to the right and add zeros in all the spaces that we add after the 2, that would be what it is laid out. But that would take us forever to write and not be very convenient. So we write it like this in scientific notation. And that's just the number of whatever it is in a mole. And in the book they did different things where they took the AMU of something and they used the number of how many grams 1 AMU is. We learned that back in chapter 3, and that's another number that probably you should know, but you can also just have it written down. It's 1.66 times 10 to the negative 24, and that is how many grams 1 atom weighs. Or, sorry, not 1 atom. Here we said 1 AMU. So like up here we had, on average, 1 nitrogen atom is 14.01 AMU. If we wanted to put that in grams, we could multiply that number of AMU times this number down here, and we would get how many grams an average nitrogen atom was. And so they worked through this in the book, and then what they did was they took the grams in a certain sample size and they divided by, they pretended they had like this many grams, and they divided by this number turned into grams, and what you ended up with was Avogadro's number every time they did that. And so they just did a ratio to kind of help you understand, like in this case, it would be the number of atoms in chemistry, or maybe the number of molecules. And so it's just the number of whatever, it's a counting number. Just like grams is something we measure using a scale, this number is something if we could count something and say, oh, I got to 6.02 times 10 to the 23rd. That means I must have a mole of that thing. Okay, so that's basically the important thing from this section. So if you can remember that number means 1 mole of that thing. That's what that number means. It's nice to know that it's Avogadro's number. And the other important thing was that this number right here, the atomic mass on the periodic table, tells us two things. It tells us the mass of a single atom in AMU, and it also tells us how many grams are in 1 mole of that thing. So that number tells us two different things. The one that is going to be more important for the rest of the book is the second one. The first one's nice. It was nice to know for the beginning of the book, but what we really need to remember now is that if we want to know how many grams is a mole of something, we go to that something on the periodic table and we find its atomic mass number, and we use that. Okay, so the comprehension check on page 199, I'm going to go through it real quick. So if you want to pause the video and try it yourself, this would be the time to pause it. All right, so the first thing says, suppose you need to collect a mole of magnesium atoms. So Mg. That's number 12 on the periodic table. I'm going to go ahead and write it has 24.31. This is the number underneath it. I'm going to write it because I know I'm probably going to need that number. All right, so suppose you need to collect a mole of magnesium atoms. So we want 1 mole of that. How many grams of magnesium would you need? Well, we already figured out that one of the things this number represents is the number, or let's not put the word number, this is grams in 1 mole. So if you want a mole, you've already got the number. You don't even have to do math for this one. 1 mole means 24.31 grams, because the pink box on page 199, number 2 tells us that atomic mass unit is the number of grams for a mole. So bam, that one's done. Number 2 says, if I have 0.500 moles of sulfur, how many atoms of sulfur do I have? So sulfur is here, and I have 0.500 moles. So I will work through this one, but one thing that you probably want to be aware of is that a question like this, I don't believe there's one on the test. So you probably would be safe skipping. Actually, I should probably go check that and make sure before I assure you that you don't need to know this. Let's see, this is the alternate. Yeah. Oh, okay. So I do have one right here. So I guess there must be one on the test. So maybe it's a good thing to do. Okay. So I want to know first how many atoms I have. So first thing we do when we get a question is, what do we have and what do we need, and what's our connection between those two? Do we have something that tells us how moles and atoms relate? We do. Let's go back and look on page 198. It says in the pink box, a mole means 6.02 times 10 to the 23. That's what, oh, I'm so sorry. That's like the worst X ever. It's supposed to be a time sign. That means 1 mole. We can fill in this blank with the word atoms. So that number, a mole means that number, but in chemistry we're talking about, if we say a mole of atom, a mole of sulfur, we're asking about the number of atoms they have. So we now have a relationship. So we can set this up. And we've been doing what's called dimensional analysis, and that's where we take a number and we say, I have this many. I'm going to write moles. I'm going to multiply it by something. This fraction is going to equal 1. I'm going to have moles on top and atoms on bottom, because moles is what I want to get rid of and atoms is what I want to keep. By putting it like this, I'll be able to cancel out the moles because that's how fractions work, and I'll be left with atoms. So I just have to set up this fraction right here so that the top and the bottom, when I consider what their units are, equal 1. So how many atoms are in 1 mole? Well, that is what this thing right here is all about. So in 1 mole, I have 6.02 times 10 to the 23. If I type this in my calculator, we don't need to worry about ones. Dividing by 1 is going to give you the same number you started with. So just type in 0.500 times 6.02 times 10, and you'll probably have to use like a little button on your calculator to raise that 10 to the 23rd power. Usually it looks something like that, or sometimes it'll look something like this. All right, and then once you type that in, you'll get the answer. I probably should pull up a calculator so I can actually do that. 500 times 6.02 times 10, and this is where mine gets fun. Let's see. All right, so mine's an X with a little Y, so I can type that and see how it made the little caret, and then I type in 23. And then when I type that in, I get a number that's like, oh, super. I'm not going to write that whole number. For right now, I'm not going to stress over scientific notation. It is important, but I want to make sure we understand the concept, so I'm just going to tell you why. If I were doing this with my regular calculator, it would have given this to me in a nice, easy way, but this one didn't. 3, 6, 9, 12, 15, 18, 21, 24, 25, 26. I had to figure out where my decimal needed to be and count over by myself because it didn't give it to me. Okay, so there's the answer to the first part, question number 2. The second part of number 2 asks a different question. It says, how many grams of sulfur would it be? So now I'm starting still with moles, but this time I want to go to grams. I need to know, this arrow right here represents how do I get from one to the other? From moles to grams, is there a relationship there? There is a relationship. It's not consistent for everything. Like in the case of moles to atoms, a mole is just a certain number of a thing. And so it's consistent no matter what element you're working with. This is how many atoms are in 1 mole. But for moles to grams, that's like saying I have a dozen bowling balls and a dozen feathers. I can't use the same conversion to figure out how many grams they are just because I have a dozen of each. The important thing is I have to figure out how many grams is in 1 bowling ball. Then I can figure out how many grams is a dozen bowling balls. If I can figure out how many grams is 1 average size feather, I can figure out how many grams is a dozen average size feathers. But I'm not going to multiply 12 times the same number for bowling balls that I would for feathers. And so in this case, when we're going from moles to grams, that's where we come back and we find this the atomic number. So sulfur is, let me flip back and see, 32.06. I have a nice chart on my wall, but it has too many decimal places because in our book we only use 2 decimal places for the atomic mass, but the chart on my wall uses 4. And a lot of charts online, actually some places it uses 3, some places it uses 2. Okay, so the important thing is we have a conversion right here. This number right here tells us that's how many grams are in 1 mole. That only applies to sulfur because we got the number off of sulfur's little square on the periodic table. We can do the same thing as before. We can set up our thing. So we have moles. We want to get rid of moles. So I put them on the bottom because they will cancel out. And I want to get grams. I have to set this up. Well, 1 mole of sulfur is the same as 32.06 grams of sulfur. And so I can set it up like this because this fraction that I'm multiplying the 0.500 by, this fraction equals 1. Then I just put it in my calculator. So let's clear that. So 0.500 times 32.06. And notice my calculator dropped the 0.500 to just 0.5. Those two zeros are significant, and when we're working with significant digits, we would care about those. But when you type it in your calculator, you can often leave off those zeros. It's not going to change your answer mathematically. All right, so the answer I got is 16.03. And because of significant digits, I need to actually round that, and the 3 would make it round down. So my answer would actually be 16 grams. It was my first answer to the first part. But if you wrote 16.03, for right now, if we can understand this concept, we'll come back in and add significant figures again later. Okay, so that is the end of that first section. Our next video will be mole problems, not just in your backyard.